Hey guys, thanks for tuning in to another video on ForgottenWeapons.com. I'm Ian McCollum, and I'm here today at Fabryka Broni in Radom, Poland. This is the modern reincarnation of a factory that was originally set up in the 1920s to produce small arms for the Polish state military. And they've invited me out today, and we're going to go ahead and take a look through the factory. So this is where they are currently making MSBS or Grot rifles, as well as some legacy products like the Beryl rifles. And they've invited us to take a look at all of the production infrastructure. So let's head inside and take a look at how all this stuff gets made. So we are going to begin this at one end of the factory and work our way all the way through to the other. And the area where we start is basically incoming material supply. So all of the basic material stock is going to come in here for sorting and grading, and then basic cutting to length, and then material can be taken and supplied to the machines, the stations in the factory, where it actually begins the process of being turned into specific parts. For example, we have a water jet cutter here that is used for a number of different parts. In this case, they are cutting basically the beginning billet, what will become the frames of Viz 100 pistols. So you can see they start with a nice large slab of material and water jet out the profile of the frames, which will then go to machining, CNC machining for completion. If we take a look at the scrap pile from the water jet cutter here, you can see a variety of other parts that they are making on it. These, for example, would be auto sears for the MSBS rifle. The Radom factory was originally, of course, put together in the 1920s, and when it had machinery like this. They keep a selection of these tools here. Most of them have been sold off to local commercial small shops, but they keep a few of them, which make for, frankly, a really cool historical exhibit. Because the way that fabrication, rifle production in a factory like this used to work would be a whole series of machines just like this, each one set up with a specific jig and fixture, as you can see here, something in operation on a magazine. But each machine has a fixture to hold one part in one position and make one cut on it. And each one of these machines would be operated by essentially an unskilled worker who is just putting the part in, running the machine forward or backward, and then swapping the part out. So this is how it used to be. And it's really cool that they still have a bunch of these machines here so that you can see that. Now, their current production is, of course, all on CNC. So let's move on to CNC production. FB does all of their own in-house barrel production. So the first stage of that is going to be on this rather large horizontal gun drill, where these four parts that you see in here are in fact four very long drill bits for drilling the original, the first center hole in the barrel material. Once that hole is drilled, then the barrel will move on to the hammer forging machine. There are some interesting details to a drill that long because, well, it runs into problems of how do you get the chips out of the hole and how do you get coolant down into the bottom of the hole. Well, if this wants to focus here, there are actually two holes in the tip of the drill bit that are for coolant that are fed from the far end of the drill. And then the way this drill is set up, you have a big, basically single long flute here that all the chips can come up through. When we get to the back end of those drill bits, right in there, you actually thread in a connection for the cooling fluid. All right, this is the totally roboticized hammer forging, barrel hammer forging machine. You can see the arm there is placing one of these barrel blanks inside the machine. Inside the blue housing there, I suppose, are a series of four carbide hammers in two pairs that hammer against each other in sequence. We have, there we go, the hammering has begun. and that is very slowly going to feed that barrel blank into the machine. This process takes about 4 minutes per barrel, and that, thank you, robot, that is the finished product that's going to come out. So you can see that it went from short and large in diameter to much longer and much smaller in diameter. So the way that this actually works is there's a carbide mandrel, what I'm holding right now, that sits inside the barrel, and you can see the rifling is engraved in reverse on the front of that mandrel. That is, they're going to hammer the barrel down over this rifling, pulling the mandrel back out of it as the barrel progresses until they get to the chamber end, at which point the whole chamber is formed the same way by hammering. They're literally squishing one of those steel rods down over a mandrel like this and turning it into a rifle barrel. It's a fantastically cool process, and in fact it's been long enough that they're getting fairly close to being done with that barrel right there. Once you have that barrel fully formed, your last major technological step is to go ahead and chrome line it. FB has their own facility for chrome lining barrels, which I'm not going to get deeper into because I don't have the right safety gear to go in there. The proof testing on barrels is done before they're finished. Well, while they're still in the white, I should say. They come down here to the shooting range. They get one proof round. So there are a series of barrels that have proof rounds loaded into them. Each barrel is then placed into a proof firing jig right there, down into a tank of water. And you have a firing pin right there connected to a firing pin handle on the door. Now we have the main CNC Hall here. The fantastic part about modern technology is that this can replace, and does replace, what would have been entire buildings worth of those old green machines. So these are multi-axis CNC machines, and they do basically all the rest of the machining processes. So what we have on this particular one are upper receivers over here for the MSBS. That, interestingly, like the Star, is a part that starts from an aluminum extrusion. It's machined down to the final form. And by having a variety of jigs and fixtures and mounting components, these machines can be extremely multifunction. So there's one of those pieces of extrusion that is clamped down, ready to go into process. These machines have a section here where you can be refitting a piece, moving a jig, taking a completed piece off or putting a new piece of raw material on, while it has a second section back here, which you really can't see into so well because of all the coolant. There we go. That is where the actual machining is going on. So a very efficient system where you don't have to let the machine stop running in order to change parts. At the end of the process, we have factory quality control with, as you would expect, a variety of basically CMMs, modern computerized measuring machines. So among the various ways to do your heat treating, one of them is a molten salt bath. We have right there. And then a much cooler molten salt bath for quenching. The heat treating room has a number of other ovens, so much more basic ovens used primarily just for surface hardening, and a very precise hardening oven. I think heat treat is a vastly underestimated or underappreciated aspect of basically the whole manufacturing process. It's almost, you could compare it to aging and wood and its effect on whiskey, in that the material you start with, the steel that you begin with, is really only half of the story. It is the heat treat on that steel that actually turns it into a finished product of good or poor quality. We have a bluing line, a line of bluing tanks over on this side of the room, and then phosphating on the other. So we will skip past some of the other machining because CNC machining is pretty much CNC machining. And we come to the final assembly area where the various guns are assembled element by element. For example, a rack of barrel assemblies here. We've got handguards over there. These are step-by-step assembled into complete guns. We then go over for marking. The marking is done by laser these days, so in this particular case, here's a rack of rifles that have all had their FB logos and production dates laser engraved on them. And there are some other markings as well, things like, well, relatively simple things, like the M-Lock logo going on the handguards. And there you go. Completed assemblies. At the end of the process then, once the guns are completely assembled, they come down here for reliability testing, basically live fire check. So each gun comes in and gets actually a full, well, these are the empty ones, a full 30 round magazine fired in single shots, bursts, and then full auto through firing ports down into that same water tank. Actually, this is done right next to the area where they do the proof testing. So they're actually down here in this particular range. We have two spots available if there's a large volume of guns that need to be test fired.
Okay. Okay.
So every individual rifle gets its sights checked to make sure that they are properly zeroed, make sure that it shoots an acceptable group before it goes into the rack for final shipment out. This is all done at 100 meters with obviously a computerized target system. The end result are racks of complete, in this case, MSBS rifles, which then go for packing and shipping, in this case, to the Polish military. All right, for proper old school original AKs, as opposed to something like the MSBS, there is a lot of stamping that is involved, and this is the stamping room. So, for example, these are stampings that are going to be pressed into safety levers. More interestingly, here we have raw AK receiver flats. the old school stamping press and jig for pressing the magazine dimples and locator holes into them. So they come out of this stamp like this, and then they go over to this gentleman, who is going to bend those into proper bent AK receivers, like so. And then they will go through the rest of the series of stampings, which I don't believe are actually set up at the moment. Here is actually the original, the very first step in the process, where sheet metal is cut into the original flat shape. And then all of the remaining dies for all the other stamping processes that FB either uses or has used in the past. So did you ever wonder how exactly they engrave those safety selector markings onto your AK? Well, this is the old version. This is one of the original pantograph machines. So what you would do is you would clamp the receiver in this fixture right here. And we have a little engraver bit right there. And I can turn that on. Turn it back off, and the way you would actually use this is you've got your plate here, which is a much larger scale version of the actual marking, and the series of arms both mean that the engraver bit is going to follow the path of this, but do it at a much reduced scale. So this gives me the pattern that I need to exactly engrave this same set of markings every time. That's the original way. Of course, today they do it with lasers. Well, I hope you guys found that interesting. A big thanks to FB for the opportunity. There are a lot of gun companies out there, manufacturers out there, who are very secretive and private about how they do everything. And it's really cool to find manufacturers like FB here in Radom who are willing to show you the ins and outs of everything that they're doing. So check them out if you're interested. Hopefully you enjoyed the video. Thanks for watching.